Exadata Storage Server Configuration, X8. Usually Exadata comes in two configuration like X8-2 and X8-8. X8-8. The difference is that Exadata X8-8 servers consists of 8 socket servers and X8-2 consists of 2 socket servers for CPU processor. X8-8 having 8 sockets of 24-core Intel Xeon Platinum 8200 processor which total up to 192 CPU cores. It also have 96 DIMM slots with total memory of 6 terabytes. With this higher compute power, the X8-8 machine is ideal for high-end OLTP databases, multi-rack data warehouse, and in-memory database workloads. X8-2. Most of the enterprise OLTP environment will be using X8-2. X8-2 having 2 sockets of 16-core Intel Xeon 5218 processor total up to 32 cores per server. Also, it contains 192 gigabytes of memory per server. High capacity and extreme flash. We have 2 types of storage options available, which is high capacity and extreme flash. In high capacity, we have 4 NVMe flash cards having about 25.6 terabytes flash storage and 12 to 14 terabytes hard disks with total capacity of 168 terabytes per server. In extreme flash, we have only 8 NVMe flash cards with total flash storage of 51.2 terabytes. This is ideal for enterprise workloads requiring extreme I/O bandwidth and high throughput. Difference between quarter and eighth rack. Here is the rack configuration of Exadata X8-2. The quarter rack system having 3 storage servers with 96 cores each along with 504 terabytes of disk storage and 76.8 terabytes of flash storage. Both eighth and quarter rack having 2 DB servers and 3 storage servers. But the difference is, eighth rack, only half of the CPU and storage space is enabled. This cost-effective configuration is for small and medium enterprises. Exadata Extended Storage Server, XT. From X8-2 onwards, Oracle introduced a new storage option called Extended Storage Servers, XT. The extended storage servers doesn't have flash drives and only 12 disks of 14 terabytes each with total up to 168 terabytes of raw capacity with hybrid columnar compression enabled. This is having only 1 CPU socket with 96 gigabytes of memory. The main advantage is that this doesn't need Exadata software license as SQL offload feature is disabled. So this is ideal for long-term data storage for archiving purposes with very less cost. Exadata Storage Server Architecture. We have discussed that the Intelligent Database Protocol, IDB, well aware about the data storage which communicates over InfiniBand network provides high throughput and cell offloading features. But there are 3 processes of Exadata storage servers playing a key role to implement these features. First is Cell Services, CellServ. Cell Services, CellSRV. Cell Services, CellServ, is the primary component of the Exadata software running in the cell and provides the majority of Exadata storage services. It services database requests for disk I/O and advanced Exadata cell services. It provides the advanced SQL offload capabilities. CellServ implements the I/O resource management, IORM, functionality to meter out I/O bandwidth at the storage layer. Management Server, MS. The management server implements a web service for cell management commands and runs background monitoring threads. It works with the Exadata Cell command line interface, CellCLI, and processes most of the commands from CellCLI. The MS is the primary interface to administer, manage, and query the status of the Exadata Cell. Restart Server, RS. Restart Server, RS, ensures the ongoing functioning of the Exadata software and services. It monitors the heartbeat with the management server and the CellServ processes. If the processes fail to respond within the allowable heartbeat period, RS process will restart CellServ and management server processes. So the purpose of RS is to make sure MS and CellSRV are up and running fine. Exadata Disk Architecture. Each storage server of Exadata having 12 disks of 14 terabytes of size, total up to 168 terabytes of raw storage. These disks will be formatted as cell disks and partitioned as grid disks and will be presented to Oracle ASM. Physical disk. The physical disk is the actual device within the storage cell. Logical unit number, LUN. The logical unit number, LUN, is the logical resource representing underlying disk with the upper software layers. Every physical disk mapped to LUN with one-on-one mapping. Out of 12 physical disks, only on the first 2 disks, there is some area around 30G reserved for OS storage area to store OS image, Exadata software binaries, config files, etc. Rest of the 10 disks, the LUN will be same size of physical disk. Cell disk. Then comes the cell disk, which is based on LUN. The first 2 disks having system area carved out and rest of the storage space on those 2 disks are mapped as cell disks. For the other 10 disks, there will be 1 cell disk for each LUN which is of same size. Grid disks. Cell disks can be subdivided into grid disks. Multiple grid disks created out of cell disks which can be presented to ASM. Cell CLI and DCLI. All these disk management activities will be done via Cell CLI or DCLI. Cell CLI is the cell control command line interface. The Cell CLI utility provides cell management functions such as cell initial configuration, cell disk and grid disk creation, and performance monitoring. You can connect with storage server and issue CLI command to invoke CLI. DCLI is the central command line utility to execute CLI commands. So using DCLI, we can execute Cell CLI commands in multiple storage servers. Cell CLI and DCLI are executed from storage servers. But if you are restricted to connect with storage servers, you can manage the disks using Exadata and Exadata executed from DB nodes.